Congestion control and quality of service. First, I want to discuss about the actually giving. I just want to give the simple idea of congestion control and quality of service. Actually, these two topics are related to each other. If we think about the congestion control, we automatically think about the quality of service. That means if we think about the improvement of the congestion control, we automatically think about the quality of service. So most techniques to prevent or eliminate congestion also improve the quality of service in the network. So today's topic is the data traffic, actually the traffic descriptor. So first thing is, what is the data traffic? The main focus of the congestion control and quality of service is data traffic, and the goals of the data traffic is divided into two parts. First is congestion control and second is quality of service. In congestion control, we try to avoid traffic congestion, and in quality of service we try to create an appropriate environment for the traffic. So under the data traffic there is two things. Number one is traffic description and number two is traffic profiles, but we will discuss today is about the traffic descriptor. So first thing is, what is the traffic descriptor? So the traffic descriptor is the qualitative values that represent an data flow, and this is the figure of traffic descriptor. The x-axis defines the seconds and y-axis defines the data rate, and this maximum data rate is called the peak data rate, and this is called max average data rate, and that is a data flow, and this is the maximum burst size. So all of this topic is so unknown to me. So let's talk about these average rate, peak data rate, and maximum burst size. So what is the average data rate? You can see here is the equation type. This is the number of bits divided by the time. So actually the average data rate is the number of bits sent during a period of time divided by the number of seconds in that period. We use this equation for this. So here is this line represents the average data rate. So why we need the average data rate, or what is the importance of the average data rate? The average data rate just indicates the average bandwidth needed by the traffic, the average bandwidth. So now the point is peak data rate. What is peak data rate? The peak data rate is the maximum data rate of traffic. That is, this line represents the peak data rate. Peak data rate is very important because it indicates the peak bandwidth that the network needs for traffic to pass through without changing its data flow. So let's talk about the maximum burst size. So what is the maximum burst size? Maximum burst size is the maximum length of time the traffic is generated at peak rate. So let's think about I just want to give an example of maximum burst size. So if data are flowing steadily at rate of 1 Mbps with a certain peak data rate of 2 Mbps for just 1 millisecond, the network probably can handle the situation because it's about the 1 millisecond. If the data rate peak data rate lasts 60 millisecond, then there makes a trouble. Okay, there is a problem for a network for handling that peak data rate, and there also rise a wide situation for handling the traffic. So that means the maximum burst size normally refers to the maximum length of time the traffic is generated at peak rate. So the last topic of traffic descriptor is effective bandwidth. So what is the effective bandwidth? Effective bandwidth is needed to allocate for the flow of traffic. The effective bandwidth is a function of these three values, that is average data rate, peak data rate, and maximum burst size. The calculation of this is so much complex because of maximum burst size, and all of these three things make this effective bandwidth. So this is the topic of traffic descriptor, the descriptive things of traffic descriptor. And next I will try to talk about the traffic profiles. Thank you for today.